Chapter 7 is about this foundational concept, which you're going to use for many years to come, called polynomials. Now, right now, when we talk about the basics of polynomials, it's going to sound super confusing to you. Just go with me. It'll all make sense later on, but just play along and fill in the blanks. The first thing that we have to talk about when we talk about polynomials is the most foundational polynomial called a monomial. And you might remember from learning about roots and prefixes, mono means one. So we're talking about one term. And a monomial is a number, a variable, or the product of a number and variables with whole number exponents. Then what we can also do with monomials is we can find this thing called the degree. And the degree is like the power of the exponent, how powerful it is, or powerful the term is, the monomial. And here are some facts about it. The way that you find it is you do the sum. And if you have a non-zero number, right, a constant is another word for a number. If you don't know that, write that down. If you have a number, its degree is 0. But the number 0 doesn't actually have a degree. So let's just look at some degrees of monomials. Or like the power, how much power the monomial has. So this is the number 10, and I just told you that numbers have a degree of 0, so that's done. And then, if there's variables involved, you add up the exponents. So in this piece right here, this x has an exponent of 1. So that's all there is, so it's got a degree of 1. But if you look at the next one, there are 2 variables. So the way that we do that is we say, well, the a has an exponent of 1, and the b has a 2, so when I add them up, the power, or the degree, is 3. And this last one just has a degree of 5, because that's all the exponent is. So it has nothing to do with the coefficient, it's all about the power of the exponent. Now there are a couple of things that disqualify something from being a monomial. And the first thing, very simply, is that you have to have one term only. Every time you have a plus or a minus, like right here, you have multiple terms. So this thing right here has 2 terms. So it's not a monomial because it's not one term. Another thing that would disqualify something from being a monomial, even though this next one looks like it's one term, it has a variable in the denominator of a fraction, which disqualifies you from being a monomial. I'll get to that in a second. But what disqualifies this from being a monomial is that the variable can't be in the denominator. Now, something that we just saw in our previous chapter was variables in the exponents. Even though this looks so much like a monomial, it's not, because your variable is also not allowed to be in the exponent. It has to be the base. So we're going to write can't have a variable in the exponent. Now, the last thing that makes something not a monomial, even though this looks so much like a monomial right here, is that you can't have a negative exponent. Now, if you remember when we learned about negative exponents, it actually forces it to go into the denominator, or you do the reciprocal. So these two, the second and this fourth one, are very tightly linked together because essentially this n has a negative exponent. It's just not visible. But the final rule is that you can have a negative exponent. All right, so all the cans and all the can'ts, let's find some degrees. And why don't you pause right now and see if you can figure out what the degrees of each of these monomials are. All of 4 of these are actually legitimate monomials. So pause quickly and tell me the degrees. I got 2, 4, 6, and 0. Hopefully you did as well. Now, back in the beginning, I told you that we were learning about polynomials, and poly, from your roots and prefixes learning, you know, means many. So this is when we have either just one monomial, but, you know, boring, or we've got multiple monomials where we add them. So a polynomial is just a monomial or the sum of monomials. Each monomial in this sum polynomial is called a term. And a polynomial with two terms has a special name. It's called a binomial, and you can see the example down below. And a polynomial with three terms, hopefully it's not a surprise, is called a trinomial. Three terms. And you can see the example down below. After that, we don't say, a quadnomial or a octanomial. We don't do that. We just say polynomial. Going back to our idea of degree, if I wanted to find out the power of a binomial or the power of a trinomial, it would be the degree with the highest value. So let's write the degree of a polynomial is the greatest degree of its terms. A polynomial in one variable is in what we call standard form when the exponents of the terms decrease from left to right. So if you look at all of these polynomials here, they all have the highest degree in the front and the lowest degree at the bottom. So all of these are called standard, they're written in what we call standard form. Standard form is very similar to reducing fractions, right? Because you could say, 4/8, 3/6, 5/10, but they all equal 1/2. And if we all agree to say 1/2, then everybody understands what each other has, and we don't have to worry about whether our answer is equal to someone else's. So whenever we write polynomials, we always write them in standard form. It's just like reducing the fraction. When a polynomial is in standard form, then the coefficient in the very front has a special name. It's called the leading coefficient. And you can see an example down here. So let's just very quickly practice putting these polynomials in standard form. So we've got this polynomial, it's all jumbled up, and we want to put it from highest degree to lowest degree. So let's just, very quickly find the degree of each term. The degree of this 15x term is 1, this would be 3, and this would be 0. So the winner, the most powerful term, is the negative x to the third. Don't forget it's negative. So it's negative x to the third. Then the next powerful term would be positive 15x and then plus 3. Just be careful that you bring the sign of the number when you switch it around. So we did the first part, we put it in standard form, and now they want us to tell what the degree is and what the leading coefficient is. Well, the degree is the power of the first term, so the degree is 3. Because the degree has to do with the exponent, but the leading coefficient, I'll just abbreviate it as LC, the leading coefficient is -1 because that's the coefficient of the first term, right here, -1. Now I'd like you to pause and try example 3 on your own, just to make sure that you understand what the chart wants you to do. This wants you to rewrite it in standard form, so if it's jumbled up, then you have to put the highest degree first. This wants the degree, so how powerful is that first term once you put it in order. And type of polynomial means, is it a monomial, a binomial, a trinomial? Is it just a general polynomial because it has, a whole bunch of terms? So that's what the headings mean, and please pause now. All right, hopefully your chart matches mine. The very first term, you didn't have to switch anything around because it was just a monomial, but the other ones you had to switch around. In just a sec, we're going to be adding and subtracting polynomials, but I don't want you to get freaked out because really all you're doing is combining like terms. So we're going to find the sum. So you want to look for terms that have the same variable and exponent. So let's look at the first one, example 4a. You've got 2x to the third, and then you scan this other polynomial and you say, is there another piece that is x to the third? And this one right here would combine. So when you add them, right, because that's what the question is asking us to do to find the sum, you would get 3x to the third because you have 2x to the thirds plus another x to the third. So now let's find another term. So we've got negative 5x squared. Do we have any other x squareds? Yeah, we do right here. That's positive 2x squared. So that gives you negative 3x squared. And then the last one, we have positive x. And then you look to see if there's anything over here. No, this doesn't combine because it doesn't have an x, so it's not a like term. So that actually doesn't combine with anything, so, boring. Plus x, and then the minus 1 just gets added on because it doesn't combine with anything either. And then you just double check, do I have the highest power here? Does it go in decreasing order? Yes, so you're done. Well, that's super colorful. All right, why don't you try letter B on your own? So that's what I got, and then you just want to double check that it's in standard form, highest to lowest degree. When you go to subtracting, you just have to do one little extra step, and it's very similar to what you did with integers. If you remember when you had the basic integers, like let's say it was, I don't know, negative 4 minus 6. What you did was you kept the first number the same, you changed the minus to a plus, and then you changed the 6 to its opposite, which was negative 6. Keep, change, whatever your saying was, add the opposite. You're going to do the same thing, but the tricky thing here now is that this whole piece stays the same. This turns to a plus sign, and then everything in here changes signs. Because you're basically like distributing the changing. So let's rewrite it first, and then basically it's just an addition problem. So we have 4n squared plus 5. Now let's change that to a plus. That's going to turn to a plus. That's going to turn to a negative. And that's going to turn to a plus. So all three of those pieces changed, and you only changed the second polynomial. But you have to remember to change everything. Now it's just an addition, and you combine like terms. So you get 6n squared minus 2n plus 9. And then you just double check that it's in standard form. If you want to try letter B on your own, you can. I'm going to change this minus to a plus. I keep the first polynomial the same, and then this one changes to a negative 3, that changes to a positive x, and this changes to a positive 8. Now it's just an addition question, so I get positive x squared, negative 2x, and then positive 13. And all I did to do that was just to combine my like terms. All right, last example. I know this video has been a little long, but polynomials is a really important skill. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. Wow, that's really irresponsible. The polynomials represent the heights in feet of the objects after t seconds, and there's actually no question. So, I don't know where the question went. I'm going to make up the question. So the question that I just made up was, how far apart are the heights at the start? So if you don't know what that's asking, the far apart is asking you to subtract. So we're going to take this polynomial and subtract this polynomial. We've got a trinomial minus a binomial. So here we go. Negative 16t squared minus 40t plus 200. I'm going to put that in parentheses to show that it is all grouped together. Negative 16t squared plus 100. So I'm going to keep the first polynomial the same. The second, or I'm sorry, the minus turns to a plus. This turns positive, and that turns negative. Now I'm going to combine like terms, and I noticed that these two terms actually just cancel each other out because one's positive, one's negative. So it'll be negative 40t plus 100 would be the distance in their heights at the very beginning. All right, you probably have a lot of questions. I'll take care of them in class and write down any questions you have for me.